GPT 5.6 Sol costs 4 times more per output token than Gemini 3.6, and that gap is verified. $30 per million to output tokens versus $7.50, and that's a real budget decision sitting between these two models. Both of these models just dropped, and people are already swapping them into production stacks, so I pulled data from 13 verified sources, including Artificial Analysis and OpenRouter, and ran Gemini 3.6 against GPT 5.6, Sol, across 5 real tests. No vendor spin, no cherry picking. And honestly, the cheaper model doesn't just win on price. It wins in ways I wasn't expecting when I started pulling the numbers. But there's one dimension where GPT 5.6, Sol pulls ahead pretty clearly, and it might be the one that matters most for your workflow. Alright, so this comparison is for anyone who's actually paying API bills or choosing a model for a real project right now. Pick the wrong one and you're either overpaying by a factor of 4, or you're leaving reasoning power on the table that your use case actually needs, and that's a real cost either way. So let's get into it. Test 1 is inference speed. When a model is slow, your users wait, your agents stall mid-task. And if you're running anything at scale, slow tokens per second means your pipeline is literally just sitting there, burning time. Speed isn't a nice to have when you're waiting on a model to finish a long task. So here's what I found, and I want to be upfront about this. Gemini 3.6 clocks 235.9 tokens per second on artificial analysis, which is actually ranked number 1 out of 189 models. GPT 5.6 Sol's claimed speed is up to 750 tokens per second, but that's only on Cerebra's hardware, not standard cloud. Different setups, so you can't really compare them directly. I was expecting a clean winner here, and what actually happened is neither model takes this one. The hardware environments are just too different to call it, so speed is a tie. Gemini 3.60, GPT 5.6, Sol 0, 1 tied. So far. Honestly, that's kind of a win for Gemini just on the fact that its number is independently verified. Test 2 is reasoning and accuracy. When a model gets this wrong, it doesn't just give you a bad answer, it gives you a confident bad answer. And if you're using it for anything where mistakes have real consequences, like code that ships or analysis someone acts on, a reasoning gap between models is something you can't just patch around. On the Artificial Analysis Intelligence Index, GPT 5.6, Sol scores 58.89 and Gemini 3.6 scores 50. That's a real gap, not a rounding difference. Gemini does post a strong GPQA diamond score of 92.8%, but I couldn't find a matching GPT 5.6 Sol number for that same benchmark, so I can't compare it directly. The index score is the cleanest like-for-like we've got. GPT 5.6 Sol takes reasoning and accuracy. I honestly thought the gap might be smaller given Gemini's strong domain scores, but 58.89 versus 50 on a composite index is pretty hard to argue with, so the score goes to Gemini 3.60, GPT 5.6, Sol 1, 1 tied. Sol's reasoning lead is real, and it's the clearest verified win in this whole comparison. Test 3 is cost efficiency, and this one hits different when you're actually running production workloads. A model that costs 4 times more per output token doesn't just dent your budget, it can make an entire product idea unviable. I've seen people build something that works great in testing and then realize the API bill at scale just doesn't make sense. What surprised me here is just how wide the gap is. Gemini 3.6 runs $1.50 per million input tokens and $7.50 per million output tokens, while GPT 5.6 Sol is $5 OS input and $30 output. That's 3.3 times cheaper on input and about 4 times cheaper on output. And Gemini also has a cached input price of 0.15 per million tokens, which GPT 5.6 Sol doesn't publish at all. Gemini 3.6 wins cost efficiency and is not close. I was expecting maybe a 50% difference, and the output gap is actually closer to 4x, which is kind of wild. Score is now Gemini 3.6, 1, GPT 5.6, Sol 1, 2 tied. If you're running any kind of volume through an API, that pricing difference alone changes the math on which model you pick. Test 4 is context window. When your context window isn't big enough, the model starts losing the beginning of your document by the time it gets to the end. You feed it a long research paper or a big code base, and it just drops things. And people run into this constantly when they're working with large files. Both models support a 1 million token input window, which is enough to read about 1,500 pages in one shot. So that's the same on both sides. Where it gets interesting is output. Gemini 3.6 publishes a 64K output token limit, which is a lot. GPT 5.6, Sol, no published output ceiling at all. That's not a small detail if you're generating long documents. Now, I want to be honest here. GPT 5.6, Sol, not publishing an output limit, doesn't tell us much either way because it could be higher than 64K or it could be lower. The lack of transparency is a real risk if you're planning around long-form generation, but I can't call it a loss for Sol based on missing data alone. Context window is a tie on input, and the output side just doesn't have enough data to score. Both land at 1 million tokens in, and only Gemini tells you what you get out, so the score stays at Gemini 3.6, 1, GPT 5.6, Sol 1, now 3 tied. Transparency matters, but a tie is the honest call. Test 5 is multimodal capability. If you're trying to feed a model an image, a PDF, or an audio file, and it just can't take that input, your whole workflow breaks. You end up pre-processing everything yourself, which adds time, cost, and points of failure. And a model that can't handle your input format isn't a model you can actually use for that task. Gemini 3.6 is confirmed multimodal, text, image, audio, video, and PDF all natively supported. GPT 5.6, Sol's documentation says nothing about image, audio, or video input. Nothing. I looked, and there's just no published multimodal capability for Sol. And while that doesn't mean it can't do it, if it's not documented, you can't build on it with any confidence. Multimodal is a tie in the scoring, because I can't penalize GPT 5.6, Sol, for data that doesn't exist yet. But practically speaking, Gemini 3.6 is the only one you can actually use for rich media right now. So the final score lands at Gemini 3.6, 1. GPT 5.6, Sol 1, 3 tied. I was expecting Sol to at least have something published here, and it just doesn't. Okay, so here's where Gemini 3.6 wins outright. API pricing is brutally cheaper at $1.50 input and $7.50 output per million tokens versus 5 cost and 30 outsource, and that's a 4 times difference on output. Gemini also has confirmed multimodal support across image, audio, video, and PDF, and it publishes a 64K output. Token limit so you actually know what you're planning around. Now, here's where GPT 5.6 Sol wins. It scores 58.89 on the Artificial Analysis Intelligence Index versus Gemini's 50, and that's a meaningful gap on a composite reasoning test. Sol also reports a coding agent index of 80 and a terminal bench-based score of 88.8%, which suggests it's pretty strong for agentic coding and command line tasks specifically. Honestly, I went into this expecting Sol to dominate on reasoning and Gemini to just be the budget option, and what I got is more nuanced than that. If you need raw reasoning power for complex tasks and you're not watching the API build closely, go with GPT 5.6, Sol. But if you're doing anything with media, running volume, or building something where cost matters, Gemini 3.6 is the pick, because output tokens run about 4x cheaper there, and that's the number that changes the math.